So let's move on to the actual brain itself. So one thing with the brain is that you can kind of break it up into three larger areas, or three smaller areas. You have kind of what's referred to as the older brain structures, the limbic system, and the cerebral cortex. The thing with these different areas is that each kind of correspond to a period of evolution. So when it came to the most basic functions that we need to survive, stuff that basically cavemen would do, but not so much higher order cognitive function, you're dealing with more older brain structures. As things got a little bit more advanced in people, it was more the limbic system being developed. And then kind of the last part, which deals with kind of the most complex human abilities, human thoughts, and cognitive processes, you get into the cerebral cortex. So here's what that looks like. Number one, this is, like I said, the older brain structures. Most simple stuff, well, it's not really simple, but stuff we need to survive. Okay, the limbic system is kind of somewhere between, and then cerebral cortex is the most complicated lines of thought, right? You could kind of almost imagine us starting with this, and then through the many years of evolution, evolving to have this whole thing, and it grows on top of it. Okay, so start out with the brainstem in terms of the older brain structures. This is also the crossover point. So left side of your brain is going to control the right side of your body. The right side of your brain is going to control the left side of your body. Okay, and this crossover happens at the brainstem, which is kind of right where the spine joins the brain. Brainstem is made up of several areas: the medulla, the pons, reticular information, and then you kind of have the thalamus. So the medulla is, again, because we're dealing with stuff that's just the most basic needed for survival, you deal with vital automatic functioning in the medulla. So you have things like breathing, heartbeat, blood pressure, and vomiting. These are generally regulated by the medulla. Going up from there, you have the pons. These pons, of course, act as kind of a bridge between the cerebellum, which we'll get to in a minute, and the medulla. Again, we're dealing here with the pons. It's kind of most basic functions, not really higher order cognitive functions. So you're talking about stuff like swallowing, bladder control, posture and equilibrium, saliva, and tears. Okay. They're also involved in movement and sleep. They kind of go together. So one thing you'll also notice is that there's a bit of overlap between the various areas. It's not all one area. So movement is also heavily based in the cerebellum. And then let's see, the reticular formation also has to do with kind of sleep and arousal, in addition to the pons. Okay. Then you get into the thalamus. So the thalamus, sorry, I'm going to slide it over here. So start with the reticular formation. This is going to filter stimuli and relay info. So when you're kind of multitasking on something, trying to ignore one thing and focus on another, the reticular formation is somewhat involved in this. It's also going to relay information to get it parts of your brain, effectively for a lot of areas. A big one with the reticular formation is that it controls arousal. So by that we mean being super alert, super awake, versus being asleep or in a coma. Okay, so when you mess with the reticular formation, if you damage it, someone would go into a coma, most likely. If you stimulated it somehow, they're going to be kind of very highly alert and awake. Okay. So then you get into the thalamus, And you can kind of think of this as the brain's switchboard. This is going to relay sensory info to and from the brain for all senses except smell. Okay, so you get vision, you hear something, whatever it might be, the thalamus is going to relay this to another part of your brain that kind of specializes in that area. So if I get a visual perception, it's going to go initially to the thalamus, which is going to relay it to the area of the brain that's specialized for vision. Okay. Okay. Yeah, and smell acts a little bit differently. Smell doesn't really go through the thalamus. Okay. So next you have the cerebellum. This is just over here in the green circle. And the biggest thing with the cerebellum is it's going to relate to motor functioning and motor learning. So again, when you're thinking of this in terms of kind of the more basic things we need to survive, obviously we'd need, without any kind of higher order cognitive thinking, obviously motor functions and motor learning. So throwing around a ball, that's going to have to do mostly with the cerebellum, but a little bit with the pons too. So like we said, it's not all isolated. Cerebellum also has to do with, well, we kind of covered movement already, and strangely enough, judging time. I'm not sure how it evolved to do that, but that seems to be the case. And generally non-verbal learning. Okay, so any kind of learning you're going to do that doesn't involve words or speaking. Okay. One interesting thing is that the cerebellum, when you drink alcohol, it's the cerebellum that's going to be affected. So alcohol actually disrupts the cerebellum, which is why you trip over yourself and fall over if you drink too much. Okay. Next up is the limbic system. So like we said, this is going to be slightly higher on the evolutionary timeline, and it's involved in slightly more complicated functions.